Okay, let's get started with this question. So all these questions will be covering grade 9 probability equation questions. So they tend to come at the end of the papers and they tend to be 5-mark questions. And it's probability mixed with algebra. So let's jump right into it and we'll do a few different case scenarios. So here we've got 5 red counters and Y blue counters in a bag. What I would always recommend with probability questions, you should always have your options and then your total. So what I mean by that is your options in this case are red counters and blue counters. So they are our options and then our total. So we should always have our options and our total. It makes doing the question a whole lot easier. So red in this case, we've got 5. Blue, we've got Y. And then our total, because there's only red and blue, therefore our total must just be 5 plus Y. So as soon as you put these 3 facts down, it's a lot easier to work with your probabilities. Okay, so we've got that. Imogen takes a counter from the bag at random. She puts the counter back into the bag. So this statement here is really important, that she puts the counter back into the bag. Reason being, the probability is not going to change after, because she's putting the counter back into the bag. So let's say, for example, she picked out a red. She then put that red back into the bag. So then if she was choosing another counter, the probability would just remain the same. So that's really important. Imogen then takes another counter at random from the bag. The probability that the first counter Imogen takes is red, and the second counter that it's red is 1 out of 9. So the probability that it's going to be red, red is 1 out of 9. Work out how many blue counters there are in the bag. Well, to work out the number of blue counters, we basically need to find Y, since Y is the amount of blue counters. And we're going to be using this fact here to be able to find out what Y is. So the probability of red, red. So the probability that the first one's going to be red is 5 out of the total, which is 5 plus Y. This is the reason why this up here helps us quite a bit. The probability that our second one is also going to be red is still 5 out of 5 plus Y, because Imogen puts the counter back into the bag. So the probability for the second time, it doesn't change. We will do a few examples where it does, like she doesn't put the counter back in the bag, and see what happens in that case. And now, since there's a probability of 2 events, so the first event and the second event, we times these together. And that just equals 1 out of 9, because they've told us that in the question. So this is the equation that we're solving to be able to find Y. So let's start solving this and solving it for Y. So 5 times 5 on the top, we've got 25 over, this is 2 brackets here. So 5 times 5 is 25. We've got 5 times Y, which is 5Y, and then we've got Y times 5, which is 5Y again, so that's just 10Y. And then we've got Y times Y, which is Y squared, that equals 1 over 9. Okay, now I'm going to cross multiply here, meaning I'm going to bring the 9 up to here, and I'm going to bring this up to here. So I'm just going to cross multiply. If you're not comfortable doing that method, you can use other methods as well, like, for example, bringing this up to the top and then dividing by 1/9. You'll still get the same answer. But I'm just going to cross multiply. So on the left-hand side, I'm going to get 9 times 25. On the right-hand side, I've got 1 times 25 plus 10Y plus Y squared. Okay, 9 times 25, that gives me 225. That equals 1 times all of this just remains the same, but I'm just going to rearrange the order. I'm going to put Y squared first, and then Y, and then the number. Now what you should notice here is that we've got a quadratic, because we've got something Y squared, we've got something Y, and we've got a number. And whenever we've got a quadratic, we must always make it equal to 0 to solve it. So I'm going to bring everything over to the right-hand side, just at 225. So I end up getting Y squared plus 10Y, and then 25 minus 225 is just minus 200. That equals 0. So this is what we're solving. Now you can use a quadratic formula, or you can use just 2 brackets to factorize to solve this. I'm going to use 2 brackets. So I need 2 numbers at times to give me minus 200, and add to give me 10. That is minus 20 plus 10. Plus 20 minus 10. So we can see 20 times minus 10 is minus 200. And then 20 add minus 10, which is 20 minus 10, that's also 10. So therefore, our two answers of y is just the opposite. So y equals minus 20 and y equals 10. Now, because y, what does y represent? Y represents the number of blue counters. It's impossible to have a negative number of counters. So we're going to ignore this one here. We will say that we cannot have a negative number of counters. You always have to give a reason why you're ignoring an answer. So we cannot have a negative number of counters. So therefore, we're accepting y equals 10. So you would just say there are 10 blue counters. And that's what they wanted to work out. So that's for 5 marks there. So we'll move over to a different example. Let's see what the next example says. Okay, so there are some red counters and some blue counters in a bag again. So they're our options. We've got red, we've got blue, and then we've got our total. So there are only 2 options. We don't know how many red and blue counters there are, but we know the ratio of red to blue. So we know red to blue is 4:1. So what could we do with that information? Well, we could say there's X amount of blue counters, since that's just representing 1. So if there's X amount of blue counters, there's 4 times the amount of red counters of blue. So we could just say 4x. So therefore, we could just say our total is 4x plus x, which is 5x, because we just added these two together. So that's how you evaluate a ratio if you're given a ratio in a probability question. Okay, so we've got 4x, x, and then 5x as the total. It says 2 counters are removed at random. So notice how they said that it's not being replaced. So just like in the last question, it said Imogen put the counter back into the bag. In this case, the counter is not put back into the bag, so the second probability will be different. So because there's going to be 2 counters removed. The probability that both counters are red is 22 out of 35. So probability of red is 22 out of 35. Work out how many blue counters there are in the bag. So blue counters is x, so we just need to find out what is x. So what can we do? Just like last time, the probability of the first one being red is 4x out of the total, which is 5x. We're timesing that by the probability that the second one will be red. The probability that the second one will be red, now that we've taken the first one out, that's red already, there's 1 less red in the bag. So the red is no longer 4x, it's 4x minus 1. And the total no longer is 5x anymore, it's 5x minus 1, because 1 counter has been taken from the bag. And we know that this equals 22 over 35 because they've given us this in the question. So you can see you've already done quite a lot of the legwork just by writing this fact down up here, because it's easy to see what your probability is in this case. And now we're just solving this. So I can see here that I can cancel these x's because there's an x on top and bottom before timesing it across. And now all I'm doing is 4 times 4x minus 1 over 5 times 5x minus 1. So the reason why I cancelled out the x's is just to make it simpler. You could leave them in, but you're just doing extra work. Okay, now I'm going to I'd probably times these all out actually first. So 4 times 4x is 16x minus 4. 4 times minus 1 is minus 4. Over 5 times 5x is 25x minus 5. That equals 22 over 35. Just like the last question, I'm going to cross multiply. I'm going to bring this 35 up to here and bring this up to here. Again, if you're not comfortable using this method, just do it in parts. So I've got 35 times 16x minus 4 equals 22 times 25x minus 5. Expanding this, 35 times 16x gives me 560x minus 4 times 35 gives me minus 140. We've got 22 times 25, 550x. And then minus 5 times 22 gives us minus 110. Okay, so let's get all the numbers to one side and all the x's to one side. So I'll bring 550x over to here. So I'm going to minus 550x. So I get left with 10x minus 140 equals minus 110. Now I'm just going to bring this number over to that side. So since it's minus 140, I'm going to add 140. So I get 10x equals 30. So therefore, to get x by itself, I just need to divide by 10. 30 divided by 10 is just 3. And we wanted to find out the number of blue counters in the bag, and we said blue is x. So therefore, the number of blue counters in the bag is 3. So the difference in this question compared to the last question is the probability of the second one changing, since the counter is not put back into the bag. And we were also given ratios as well, so we had to define our own version of x. That was a pretty good question. Let's do the next question. Okay, so there are 4 red counters and x blue counters in a bag. So our options, again, are red and blue. So our options are red and blue. There's no other options. And let's just put a total down. So red, we've got 4. Blue, we've got x. So therefore, our total is 4 plus x. Okay, because we've only got red and blue. 2 counters are removed from the bag at random. It's not being replaced, so therefore the second probability will change. That's the importance of this sentence here. The probability that both the counters are blue is 1 over 3. So probability of blue is 1 out of 3. Work out the value of x. So we're basically finding out what is the amount of blue counters. So the probability, the first one will be blue is x out of the total, which is 4 plus x. Now, this probability, the second one's going to be blue. Since the counter is not being put back into the bag, we've got 1 less blue counter. So therefore, we don't have x amount of blue counters, we've got x minus 1. With the total, we no longer have 4 plus x as a total. We've got 4 plus x minus 1. So we've got 1 less total now as well. And that just equals 1 over 3. Let's simplify this. So I get x over 4 plus x times x minus 1 over 4 minus 1 is 3. So 3 plus x equals 1 over 3. Now let's put them together. Okay, so on the top we've got x. I'd recommend putting brackets around these so you expand correctly. So you can use a grid method or FOIL. X times x is x squared. X times minus 1 is minus x. For the denominator, 4 times 3 is 12. 4 times x is 4x, and x times 3 is 3x. 4x add 3x is 7x. And then we've got x times x, which is x squared, and that equals 1 over 3. Just like last time, I'm going to cross multiply. I'm going to bring the 3 up to here, and I'm going to bring all this up to here. So I get 3 times x squared minus x equals 1 times 12 plus 7x plus x squared. Okay, let's expand. We get 3x squared minus 3x equals 1 times all of this. All this is just going to remain the same. I'm just going to change the order and put it x squared, then my x, and then my number. So x squared plus 7x plus 12. Okay, so just like that first question we did, I've noticed we've got a quadratic, and we always make quadratics equal to a 0. I know it's a quadratic because it's got an x squared, it's got an x, and it's got a number. Okay, so I'm gonna bring everything over to the left-hand side. Reason why is because I want the x squared to stay positive. If I minus 3x squared to the right-hand side, I'll end up getting minus 2x squared. I don't want my x squared to be negative. It's easier keeping it positive. So I'm going to bring everything from the right-hand side to the left-hand side. So minusing x squared, 3x squared minus x squared is 2x squared. And then done that. So we've got 7x now. So since it's plus 7x, we're minusing 7x. Minus 3x minus 7x is minus 10x. And then the 12, since it's plus 12, the opposite is minus 12, that equals 0. I can make this whole thing simpler and divide it by 2, since they're all multiples of 2. 2x squared divided by 2 is x squared. Minus 5x minus 6 equals 0. So you can use a quadratic formula, or you can just factorize to solve this. Just going to factorize. So two numbers at times to give me -6 and add to give me 5. -2 times 3. No, -6 times 1. Yeah, so -6 times 1, because -6 times 1 is -6. -6 add 1 is -5. So therefore, x equals 6 or x equals -1. But because x represents the number of blue counters, x can't be a negative number. We can't have a negative number of blue counters. So we're going to ignore this one, say counters cannot be negative. So therefore, x equals 6. And that's our final answer for that one. Okay, that was pretty good, that one. Okay, moving on. Let's do question 4. So there are n counters in a bag. Okay, so this time they've already told us the total. The total is n. 4 of the counters are red and the rest are blue. So again, it's red and blue, where red is 4 and the rest are blue. So how could we determine that? Well, if there's only red and blue, if the total is n and there's 4 red, then that must mean the remaining are blue. So we can just say n minus red, which is 4, is blue. So that's how we've evaluated it. Okay, so we've got our options, we've got our total. It says Ross takes a counter from the bag at random and does not replace it, meaning he doesn't put it back into the bag. He then takes another counter from the bag at random. The probability that he takes 2 blue counters, so probability of blue is 1/3. Show that n squared minus 13n plus 30 equals 0. So we're just doing what we've been doing. So the probability of blue, the probability the first one's going to be blue is blue out of the total. Blue, we said, is n minus 4 over the total, which is n. And because he's not replacing the counter, so he's not putting it back into the bag, the second probability will be different. So there's one less blue one now. So it's not n minus 4, it's n minus 4 minus 1. And then the total is no longer n. We've now got one less, so it's n minus 1, and that equals 1/3. So that's what we're figuring out. Let's simplify the top here. So we get n minus 4 over n times n minus 4 minus 1 is -5 over n minus 1 equals 1/3. Let's times these two out. I'd recommend putting brackets in. N times n is n squared. N times -5 is -5n. And -4 times n is -4n. -5n minus 4n is -9n. And then we've got -4 times -5 is +20 over n times n, which is n squared. N times -1 is -n equals 1/3. I'm going to cross multiply again. So I'm going to bring the 3 up to here. And I'm going to bring all this up to here. So I get 3 times n squared minus 9n plus 20 equals 1 times n squared minus n. Now let's expand. We get 3n squared minus 3 times 9, 27n, plus 3 times 20, well, 3 times 2 is 6, and then add a 0. And then 1 times this, it just remains the same, so n squared minus n. Let's bring everything to one side. I'm going to keep the n squared positive, so I'm going to move these over to the left-hand side. So minusing the n squared, I get 2n squared. And then since it's minus n, I'm going to plus n. Minus 27n plus n gives me minus 26n plus 60 equals 0. Now, they all are multiples of 2, so I could just divide the whole thing by 2. I get n squared minus 13n plus 60 divided by 2 is 30, and that equals 0. The question said show that n squared minus 13n plus 30 equals 0, and we've just shown that here. Okay, so that was for 5 marks. The second part says find the value of n. So this question is similar to all the previous ones, but they've broken it down into a part A and a part B. So let's find the value of n. We just need to solve this. So that was part A. Part B, we're finding n. So you could use a quadratic formula or you could factorize. Let's attempt to factorize. So let's put n. Remember, n represents the total number of counters. So always go back to context, like what am I exactly finding? You're finding n, which is a total number of counters. Two numbers at times to give me 30 and add to give me minus 13. Minus 10 times minus 3 is 30, and then minus 10 add minus 3 gives me minus 13. So therefore, n equals 10 and n equals 3, but we can't have two values of n. So which one is it? And this time we don't really have a negative number that we can just totally disregard. So we need to go back to the context of the question. N is the total number of counters, and we know the number of red is 4. We pull that from here. The number of red counters is 4. So it's impossible for the total to be less than the number of red, because the total is red plus blue. So therefore, we can't have a number less than 4. So we are going to ignore this one here. So we say the total cannot be less than the number of red counters, which was 4. So therefore, n equals 10. That's our final answer. So that was for 7 marks. Okay, we've got one more question to do. Okay, moving on to this final 5-mark question. Okay, so this time we're not doing counters, we're doing pens in a box. So it says here, there are only green pens and blue pens in a box. Okay, so we've only got green and we've got blue. Okay, there are 3 more blue pens than green pens in the box, and there are more than 12 pens in the box. Okay, so we've got a bit of riddles here, but we know there's green, blue, and the total. Okay, so there's 3 more blue pens than green pens in the box. So if we say the number of green is x, because we don't know how many green pens we've got, there's 3 more blue pens than green pens, so we could just say x plus 3. Because there's 3 more blue pens than there are green pens in that box. And it says there's more than 12 pens in the box altogether. Okay. Maybe this might help us after when we're actually trying to find out what x is. Maybe there's 2 answers we need to choose from. So there's more than 12 pens in the box. So if we know the number of green is x and we know blue is x plus 3, surely the total of this is going to be adding these two together. So x plus x is 2x, and then we've got 3. So our total is 2x plus 3. Same as last time, but we just had a little bit of a riddle to figure out there. Okay, Simon's going to take 2 pens from the box. So he's not putting the box back in. The probability that Simon will take 2 pens of the same color is 27 out of 55. So this one's a bit tricky. The same color, we could have the probability of it being green, green, or we could have the probability of it being blue, blue. Now, when we've got 2 different probabilities, remember we add them together. So you times them in, for these 2 inside, you times them when you're working them out, but you add them together once you find out them 2 probabilities that you found. Okay, and the total of that equals 27 out of 55. There's no other possibility. We could only have green, green, or we could have blue, blue. That's the only way we can have 2 pens of the same color. Okay, so work out the number of green pens in the box. We basically need to find x, because we've defined green as x. Okay, so the probability of green, green. Let's do this first. So the probability of it being green, green, so we've got a bit of extra steps to do here, is going to be, the first one being green is x over the total, which is 2x plus 3, times, now because we've taken 1 green pen out and we've not put it back in, we've now got x minus 1, so we've got 1 less green pen in the box, and we've got 1 less in the total, so we're going to minus 1 from the total. We don't know what that equals, because we're going to put it in for this part here. So let's simplify that. So we get x over 2x plus 3 times x minus 1 over 2x plus 3 minus 1 gives us 2x plus 2. Timesing that out, I'm going to put brackets around here. You can use a grid method to expand or just your normal FOIL. X times x is x squared, x times minus 1 is minus x, over 2x times 2x is 4x squared, 2x times 2 is 4x, and we've got 3 times 2x, which is 6x. So 4x add 6x is 10x. Just double check that. 4x add 6x. Yeah, okay. And then 3 times 2 is just 6. If we can't simplify that, we'll leave that as is. So we've got the probability of it being green, green over here. Now let's find the probability of it being blue, blue. So this part here. So probability of blue, blue. Well, the probability, the first one's going to be blue, is x plus 3 over the total, which is 2x plus 3. And the probability, the second one's going to be blue. We've taken one blue out. So therefore, it's going to be not x plus 3, but x plus 3 minus 1. So we've taken one out. And again, from the total, we've got 2x plus 3, but we've minus 1 because we have one less in the total. Let's simplify that down. So we've got x plus 3 over 2x plus 3 times x plus 3 minus 1. So we've got x, 3 minus 1 is 2, over 2x, and then 3 minus 1 is just 2. Okay, now let's expand this. I'm going to put brackets around all of these to expand correctly. We've got x plus 3 times x plus 2. So x times x is x squared. X times 2 is 2x, and then 3 times x is 3x. 2x add 3x is 5x. 3 times 2 is 6, over 2x times 2x is 4x squared. Well, actually, this denominator, 2x plus 3 times 2x plus 2, is exactly the same as this top one here. So I don't need to do that work. I can just copy what's on bottom. So 4x squared plus 10x plus 6. Okay, so we've now got the probability of it being blue, blue. So what I now need to do is I need to add these two together. So the probability of getting green, green, the probability of getting blue, blue, we add them together. So that's that's what I brought up here as well. And them two added together gives you 27 over 55 because it's told you that in the question. So the probability of it being green is x squared minus x over 4x squared plus 10x plus 6. We're adding that to the probability of blue, blue, which is what we've just found, x squared plus 5x plus 6 all over 4x squared plus 10x plus 6. And we know that equals 27 out of 55. Now this is what we're solving to find x. So it looks a bit daunting, but let's make it look a bit simple. Your basic fraction rules, when we're adding two fractions, the denominator has to be exactly the same. And thankfully they are. Otherwise that would have been a bit more work. So let's add our fractions together and combine them. We've got x squared add x squared, which is 2x squared. So I've done that. Minus x plus 5x is plus 4x. And then we've got plus 6. Okay, and that's all over our denominator, 4x squared plus 10x plus 6. Remember, when we're adding fractions, the denominator just stays exactly the same. That equals 27 over 55. Now I'm just going to cross multiply here. So just like last time, I'm going to bring the 55 up to here, and I'm going to bring all this up to here. 55 times 2x squared plus 4x plus 6 equals 27 times 4x squared plus 10x plus 6. Okay, so I've just brought each of them up to each side. Okay. Let's now expand and simplify and see what we get. Okay, 55 times 2 is 110x squared, plus 55 times 4, 220x, plus 6 times 5, 30, equals 27 times 4, 108x squared, plus 270x, because 10x times 27 is 270. 6 times 27 gives me 162. Let's bring everything to one side because we've got a quadratic. What do we always do when we have a quadratic? We make it equal to 0. I'm going to bring everything over to the left-hand side to keep the x squared positive, since this one is smaller. So we get 2x squared. When we minus that, 110x squared minus 108x squared is 2x squared. 220x minus 270x is minus 50x. And we've got 30 minus 162 gives us minus 132 equals 0. They're all multiples of 2. Let me see if I can just bring all this up slightly. We'll make it just so there's a bit of space. Be pretty epic if you could do this in the exam with your working out to keep it neater, but can't do that. Okay, so all of this is a multiples of 2. They're all even numbers. So I'm going to divide the whole thing by 2, make it easier. X squared minus 25x minus 132 divided by 2 is minus 66 equals 0. Okay. Just going to double check I have done this right. Because I've got a different answer to what they have here. Okay, they've got something different here in the mark scheme, so I'm just wondering where I've gone wrong, or potentially the mark scheme could be wrong. So 555 times, so that's 110x squared. Okay, I think I'm confident in my answer, to be fair, even though theirs is different for some reason. Twenty-seven times 662 6 times 55. Okay, that's where I went wrong. Right, spotted it eventually. 6 times 55 is not 30. Not sure why I wrote 30 there, but we found it. 6 times 55 is 330. Okay, sorry about that. Okay, so then therefore this is going to change now. Okay, so we've still got, actually, you know what? I'm going to keep all that. It's just the last number that's incorrect. Just this one here. So 330 minus 162, we get 168 equals 0. Dividing that 168, we get 84. It's because the mark scheme has used a different way of working out, so it was quite hard to spot where I made a mistake. But anyways, we've got this. You could solve using the quadratic formula, just use 2 brackets. And try 2 brackets. 2 numbers at times to give me 84 and add to give me minus 25. Minus 4 and minus 21. I probably would use a quadratic formula there, to be fair, just because it's quite hard to think of 2 numbers that times to give you 84 and add to give you minus 25. So therefore, x either equals 4 or x equals 21. Now, in the question, it says there are more than 12 pens in the box. So the total, 2x plus 3, has to be more than 12. So therefore, we're going to take the bigger number, because if I plug x equals 4 in, 4 times 2 is 8. 8 add 3 is 11. So therefore, x cannot be 4 because of that statement they've said here. There has to be more than 12 boxes, 12 pens in the box. So therefore, x equals 21 because there's more than 12 pens in the box. So that's the reason why they told us that statement. So yeah, that was for 5 marks. So sorry about that last part, that little mistake that I made. That 330, that caught me out here. Yeah, that's all probability equations covered. That's all grade 9. So hope that was helpful, and see you on the next one.